Okay, let's dive into this because there's a quiet revolution happening in our fields, and it's happening far, far away from the cloud data centers of Silicon Valley. It's a movement powered not by big tech, but by a powerful drive for independence. Today, we're going to look at a system that's designed to put farmers back in control of their own land. And, it all starts with their data.
And this one line, right here, this is the key. It's pulled from the project's own documentation, and it just perfectly frames the central conflict in modern farming today. See, it's not just about the crops anymore. It's about the incredibly valuable data that the land itself produces. So the real question is, who gets to harvest that?
So to really get the solution, we first got to understand the problem. Let's call it farming's big data problem. The way we do smart agriculture right now, well, it's kind of built on a shaky foundation. And it really boils down to two huge issues: who actually owns the data and who's left holding the bag when the whole system fails.
The first flaw is a concept the document calls data sharecropping. Think about it. A farmer works the land, they invest in all the equipment, and they generate this priceless data about soil health, crop yields, you name it. But in the current setup, big tech giants like John Deere and Bayer are the ones who get to harvest that data for their own benefit. It basically turns the farmer into a tenant on their own digital land.
And that brings us right to the second big flaw: vulnerability. On one side, you have the current cloud-dependent model, where a corporation owns your data, and everything relies on some centralized server. Its Achilles heel? It's right there at the bottom: catastrophic dropouts. We all know rural internet can be, well, less than reliable. When it fails, the entire smart system just goes dark. So what's the answer? Well, this leads us to a pretty radical solution. What if a farm could go completely off-grid? Totally disconnect from the internet, and in doing so become smarter, more efficient, and way more resilient than it ever was before. The whole principle is called island mode. It's all about transforming the farm into its own self-sufficient digital ecosystem. Everything, the sensors, the AI, the machinery, it all communicates on a private local network. The farm becomes its own intelligent, self-regulating organism, completely air-gapped from the outside world. Okay, so how does it actually work? Well, every organism needs a nervous system, right? In this case, it's built from three parts. First, you've got these LoRaWAN mesh beacons. They're low-power, long-range radios that create a huge private network that can cover thousands of acres. Second, you have sensors out in the fields acting like nerve endings, constantly reporting on everything. And finally, these industrial interfaces plug directly into the farm's existing muscles, the old-school pumps and valves. And of course, every nervous system needs a brain. Here, it's an AI model called OpenClaw. But, and this is the most crucial part, this brain lives on the farm. It's probably sitting in a ruggedized box in the barn, not in some data center 1,000 miles away. It's a specialized AI fine-tuned on botanical science and soil chemistry, and it's making decisions right there on the edge. So how does this system actually think? Let's walk through 3 real-world scenarios that show this local brain and nervous system in action. It's pretty cool. First up, irrigation. The classic way to do it is just water on a fixed schedule. It's simple, but man, is it inefficient. You end up wasting water during a downpour, or even worse, your crops are starving during a surprise heat wave. All right, so here's the new way. The field sensors report the soil's getting dry. But instead of just blindly opening the valves, the local AI checks its own onboard weather barometer. It sees a pressure drop and predicts rain is on the way. So what does it do? It waits. It saves thousands of gallons of water. This isn't just simple automation. This is localized, predictive intelligence. Next, let's talk about pest control. The traditional method is just brute force. Spray the entire field with pesticides. It's expensive, it's wasteful, and it's just awful for the long-term health of the soil. The Sovereign solution, though, is surgical. A drone or a rover patrols the field, and its camera feeds video directly to the local AI. Using computer vision, it identifies a single weed. Then, and get this, it can either dispatch a tiny microdose of herbicide just on that one plant, or even use a little robotic arm to physically pull it out. We're talking total precision, with basically zero waste. And the final problem is a big one. It's all about money and trust. How can a farmer prove they're using sustainable practices so they can sell carbon credits without having to share all their sensitive business data, like crop yields and financials, with a bunch of auditors? The system solves this with something that is, frankly, brilliant. It's called a split ledger.
All the sensitive business data, the financials, the secret sauce of their crop strategy, that all stays on a private ledger that only the farmer can see. But the verifiable proof, like gallons of water saved or the increase in soil carbon, that gets cryptographically signed, which means it's locked with a digital signature that is impossible to fake, and then it's published to a public ledger. This creates an unchangeable proof of sustainability without revealing a single trade secret.
Okay, so this all sounds great in theory, right? But farming is messy. What happens when the real world gets involved? What if a deer decides to chew through a sensor cable?
Well, the system is designed for chaos. The AI is smart enough to spot weird readings. If one sensor says there's 0 moisture, but all its neighbors say 45%, it knows something's up and flags that sensor as faulty. The hardware itself is ruggedized and waterproof, and crucially, it uses feedback loops. It doesn't just tell a valve to close, it checks a flow meter downstream to confirm the water actually stopped. If it didn't, boom, it shuts down the main pump. No catastrophic failures.
So when you start putting all these pieces together, you realize you're looking at something much bigger than just a new gadget for farming. You're looking at the independent future of food and the massive strategic impact that could have.
And listen, this isn't some far-off futuristic fantasy. The internal document actually lists a target MSRP for the core software and the gateway adapter at just under $1,500. That price point grounds this whole thing in a very real commercial reality. It makes it accessible not just to massive corporations, but to regular family farms and co-ops.
And this final quote from the document, it just sums it all up perfectly. This technology does more than just optimize farming. It's about fundamentally changing the power structure. It's designed to turn a simple plot of land into what they call a sovereign asset, something that is self-regulating, profitable, and most importantly, truly independent.
Which really leaves us with one last big thought. If you can take a farm completely off-grid and make it smarter and more sovereign than ever before, what's next? What other industries, from manufacturing to logistics, maybe even to energy, are ready to unplug from the cloud and declare their own independence?